Welcome to this explainer. You know, we plug in our headphones or turn on a speaker every single day, right? We don't even give it a second thought. But today, we're diving into something super fascinating. We're going to demystify exactly what lives hidden away inside those little plastic casings. We're basically going to take this seemingly chaotic miniature metropolis, an audio circuit board, and break it down piece by piece. We'll map it all out so it actually makes sense. So get ready, because by the end of this, you are absolutely going to look at your everyday audio gear in a completely new light. So, what exactly happens inside an audio filter? Honestly, it's a question that rarely crosses our minds when we just hit play on our favorite playlist. When you hold a raw circuit board, it's kind of easy to just see this random, chaotic jumble of metal, plastic, and, colorful little cylinders. But the thing is, every single microscopic component on there has a highly specific job. Working together, they take raw electrical signals and sculpt them into the rich, dynamic sound that hits your ears. Today, we're solving that mystery together. Now, take a look at this incredibly vibrant red circuit board. Notice the crisp white lettering in the bottom corner marking it specifically for MP3s? Well, this striking piece of hardware is going to be our entire map for today's explainer. We're going to trace an audio signal's journey right across this landscape, literally from the exact moment it enters, through all of its crazy twists and turns, straight to the finish line, where it exits as perfectly filtered sound.
Okay, let's dive into this. Section 1. Meet the two-channel filter.
When we break down all that initial visual clutter into a simple inventory, the board instantly transforms into this really digestible list of parts, all working as a team. Right smack in the middle, we've got our single central IC chip. Surrounding that are 16 neatly arranged striped resistors. Those are the little tan cylinders with the colorful bands. We can also spot 8 prominent blue electrolytic capacitors standing up, 2 flat yellow ceramic ones, a pair of tiny orange and black diodes, and finally, 2 blue adjustable gain pots with those little white dials. See? When you count them out like this, it's not a jumble anymore. It's a specific cast of characters ready to play their parts.
Now, check out the bottom right corner. You'll see the text 2-channel. That just stands for 2-channel, and this is absolutely crucial because it means this board is built for stereo sound. It's not just processing one flat stream of audio, it is simultaneously processing completely independent left and right audio signals. That right there is exactly what gives your music that awesome, immersive, wraparound feeling in your headphones.
And this brilliantly illustrates how the board handles those two separate channels. If you imagine a line drawn right down the center of the board, it's almost perfectly symmetrical. The components on the left side, which, counterintuitively, handle the right ear's audio with R gain and R op, perfectly mirror the parts on the right side handling the left ear's audio with L gain and L op. It's a gorgeous piece of physical engineering, literally 2 identical pathways for 2 streams of sound.
Moving on to Section 2, giving the circuit power.
Direct your eyes right to the bottom center of the board, tucked neatly between those bottom capacitors. That's where you'll find the electrical power terminals. It's unmistakably labeled power, with 3 distinct connection points: negative V, GND, and positive V. This is exactly where an external power supply gets soldered in. Because let's face it, without electricity flowing into this exact spot, our audio filter is basically just a silent piece of modern art. It absolutely needs this foundational energy to wake up.
Let's quickly decode a term from that power section, GND. That stands for ground. In any circuit, the ground is the electrical baseline, the reference point of 0 volts. So the negative V gives negative voltage, positive V gives positive voltage, and the ground makes sure the electricity has a safe, stable path to actually complete the circuit. Kind of takes the intimidation factor out when you know the vocabulary, right?
All right, Section 3, tracing the audio input. Let's see where the sound actually enters.
Look all the way at the top edge of the board. Notice that upside-down white text? It reads IPLLGNDR. Those little silver metal rings right above the text, those are the exact entry points where the raw audio from an MP3 player gets fed into the system. You've got L for the left channel, R for the right channel, and they share a ground point in the middle just to keep everything clean and free from electrical noise. Just to be crystal clear here, that IP printed on the board stands for input. This is literally step 1 of the audio's physical journey. Think of it like the main gate to our micro city. The raw, unfiltered MP3 signal knocks on the door right here, and once it crosses this threshold, it is ready for a major transformation.
Which brings us to Section 4, the central processing brain.
So once the signal gets through those top gates, it definitely doesn't just sit there. It immediately races down the microscopic copper roads printed on the board, heading straight for downtown.
And here is that downtown processing center. Check out this large rectangular black integrated circuit chip smack in the absolute center. It's prominently labeled 25A-KSK TL084CN. In our microcity, this dark chip is the brain of the entire operation. Everything happening here revolves around the routing and calculations inside this single black box.
But here's the crucial point. This brain doesn't work alone. Remember all those clustered components we counted earlier? The 16 striped resistors and those blue capacitors? They are meticulously arranged around that central chip for a very specific reason. They work directly with it to filter frequencies. Imagine them as highly specific toll booths. They restrict certain electrical frequencies while letting others sail right through. That's how they shape and clean the sound.
Next up, Section 5, controlling the audio gain.
Now, what's really interesting here is that up until now, everything's been pretty automatic, right? Just electrons flowing down copper paths. But look at these mechanical pieces, the two blue components with the white centers flanking the middle chip. These are adjustable trimpots, beautifully labeled R gain and L gain, with a tiny 503 printed right on the dials. Notice the little crosshairs? Those are literally slots for a screwdriver. This is exactly where a human can step in and manually tweak the rules of the circuit on the fly. To understand what twisting those dials actually does, we just define the word printed right next to them: gain. Gain is simply an adjustment that alters the amplitude, or the intensity, of the audio signal. By physically turning these dials, a technician gets independent, hands-on control over how hot or intense the left and right audio paths are before they leave the board. Basically, they're fine-tuning the volume and power.
And finally, Section 6, the final filtered output.
Let's step back for a second and see how this all builds into a complete story. It's a three-step journey. Step 1, the raw MP3 signal enters at the top IP pins. Step 2, the signal travels to the center, gets filtered by the TL084CN chip, and tweaked by those human-controlled gain pots. In Step 3, the fully processed, optimized signal routes down to the bottom to exit via the OP pins. And here is exactly where that journey finishes up. Look at the lower left and lower right corners. See the silver metal rings labeled ROP on the left and LOP on the right? These are the exit gates. The separated left and right audio signals are routed to these corners, completely ready to be sent through a wire out to an amplifier or directly to your speakers.
Just to close the loop on our vocabulary here, output stands for output. This is the literal finish line of our microcity. The audio leaving through these specific metal rings, it is no longer that raw, unrefined sound that knocked on the door at the top. It's been balanced, filtered, and totally perfected by the physical architecture we just explored.
It's honestly mind-blowing how much complex physical reality exists behind a simple sound file playing in our ears. So, I want to leave you with this. The next time you adjust the audio on your device, or put on a pair of stereo headphones, will you picture this perfectly organized microcity silently working behind the scenes? Because every single chip, dial, and copper path plays a vital role in delivering the music you love. Thanks so much for joining me on this explainer today. Keep learning and stay curious.